Alright, now we're going to talk about the normal line. And so a normal line to a curve is a point that is perpendicular to the tangent line at that point. And so when we talk about perpendicular, that means my slopes have the opposite reciprocal. The opposite reciprocal. And so we're going to use what we've learned about the tangent line. So it's a very similar process, but instead of finding m, we're going to find 1 over m, negative 1 over m, where m still maintains the slope of my tangent line. And so I'm going to actually use the same process. I need to find the y value if it's not given. I need to find the derivative of f, but instead of just going ahead and using that m, I need to find the opposite reciprocal value of the slope of the normal line. I can't just use m, that would be the tangent line. So remember, when we went to the opposite reciprocal. And then now we're going to use our point slope formula. Number 1, find the equation of the line normal to h of x is equal to 3 divided by x squared at x is equal to negative 4. So let's go ahead and change our h of x into something that looks a little bit nicer. And so we're going to have 3x, and so it's from the denominator, so we're talking about negative 2. And so if I was going to find the derivative, h prime of x is going to be equal to negative 6x to the negative 3. And so let's go ahead and find the slope of my tangent line so I can use the opposite reciprocal. So h prime of negative 4 is equal to negative 6 negative 4 to the negative 3. And so if I was going to look at that, that would be negative 6 divided by negative 4 to the third, which is equal to negative 6 times 16, so negative 64, which is 3 over 32. And so that is our m. I want to find my perpendicular slope. So I need to find the slope that's perpendicular. And so that would be negative 32 over 3. And so I have a slope. I have an x-coordinate. But I don't have my y-coordinate yet, so let's go ahead and go back to our parent function, which is located right here. And let's plug in. So we have h of negative 4 is equal to 3 over negative 4 squared. So I went ahead and moved the square to the bottom, so notice that this negative right here means it's from the denominator. And so I just went ahead and put my x back down in the denominator. And so be careful, the negative 4 has nothing to do with this negative up here, okay? That negative means that my x is from the denominator. So I went ahead and returned it so I have a better understanding of what's going on. So this is going to be equal to 3 over 16. So my tangent, or my normal line is going to be y minus 13 over 16 is equal to negative 32 over 3 times x plus 4. Alright, number 2. If it exists, determine the equation of the line normal to the following function at the breakpoint. So let's go ahead and let's find our derivative, and then we do that by writing g prime of x is equal to, in this case, it's going to take the derivative where x is less than 1, so this would be the top would be 2x, or x is less than 1, and the bottom would be 2, or x is greater than or equal to 1. And so we want to find where at the break point. What they mean by break point is this 1 right here. This is where my function is changing from one side of the piecewise function to the other side of the piecewise function. And so if I wanted to find, first I need to make sure if my function is going to be continuous. So I just want to just double check. And so what I'm going to do is, okay, g of, let's see here, so let's do g of 1 just so I can see my point. My point's going to be equal to 4. And if I plug in my limit as x approaches 1 from the left, x squared plus 3, if I plug in 1 here, I'm still going to get 4. And I just want to double check, does that equal the limit as x approaches 1 from the right of 2x plus 2. Again, if I plug in 1, I'm still going to get 4. So at least it's continuous. Now I just want to make sure, double check it's differentiable. And so I'm just going to use my derivative. So if I have the limit as x approaches 1 from the left, okay, again, this is the left side, does that slope equal the same as the right-hand side? So continue, so 2x, that's the left-hand slope, which is equal to, if I plug in 1, I'm going to get 2. And if you notice, you don't go ahead and see it, it's going to equal the limit as x approaches 1 from the right of 2. And so we're okay. So it's both, it's continuous, it's also differentiable. So this is the first time you've seen me to go through a problem of the full time of differentiability. So if you need to prove later on a test, if you have to prove differentiability, this is what I'm talking about. You show the continuity, and then this is how you use limits with the derivative to find to make sure improve differentiability. So far so good. So we're good on it's differentiable, and we're also good on that it is continuous. All right. So let's go ahead and find the equation of our normal line. And so if we find g of, we have the x coordinates, let's find the y coordinate. So g of 1 is going to be equal to 4. And my slope, so g prime of 1, which is my slope, for my tangent line is going to be equal to 2, but my perpendicular slope is going to be equal to -1/2. And so my tangent line is going to be y minus 4, or excuse me, not tangent line, normal line is y minus 4 is equal to -1/2 x minus 1. Number 3, find the slope of the normal line to the graph of f of x is equal to 4 times the square root of x minus 2x at 9, -6. So it's nice they went ahead and gave us the y-coordinates. All we need to find now is our normal slope. So let's go ahead and find our tangent line and then do the opposite reciprocal. So my f, I'm going to fix it so I can in power form. So this will be 4x to the 1/2 minus 2x. So my f prime is going to be 2x to the -1/2 minus 2. And so f prime of 9 is equal to 2 times 9 to the -1/2 minus 2. Well, if I was going to fix that, again, this negative half means it's from the denominator. So I know I need to put the 9 in the denominator. Half means square root. I know it's square root because that's where it came from. So I have 2 over the square root of 9 minus 2, which is equal to 2 over 3 minus 2, which is, let's see here, 2/3 minus 6/3 is equal to -4/3. And so if I wanted my perpendicular slope, that would be 3/4. So my tangent line, or excuse me, again, my normal line, not tangent line, my normal line is y plus 6 is equal to 3/4 x minus 9. Suppose p and q are differentiable functions with the values in the table below. Find the equation of the line normal to r of x at x equals -2, provided r of x is equal to p of x minus 3 times q of x. So r of x is a combination of two other functions that are listed in my table. I already have my x-coordinate for my normal line, which is -2. How about I find the y-coordinate first of my normal line? And so if r of x is equal to p of x minus 3 times q of x, then r of -2 is going to equal to p of -2 minus 3 times q of -2. So I'm going to come to my table. So I want to find what is p of -2. Well, I notice that p of -2 is equal to 5. So I'm just going to write is equal to 5 minus 3. And I want to find what is my q of -2. Well, q of -2 in this case is 7. So I'm going to write 3 of 7. So I get 5 minus 21, which is equal to -16. Now I want to find my derivative. Well, if I take the derivative, so if r of x is equal to p of x minus 3 times q of x, then r prime of x is equal to p prime, so I'm just taking the derivative of each, so the derivative of p is p prime, minus the derivative of 3qx would be 3q prime of x. And so r prime of -2 is going to equal to p prime of -2 minus 3 times q prime of -2. And so if I plug those values in, I'm going to get p prime of -2, which is -1, minus 3 times q prime of -2, which is 6. And so I'm going to get -1 minus 18, which is -19. And so my perpendicular slope, my normal line slope, is going to be equal to 1 over 19. And so if I put together my y-coordinate, x-coordinate, so here in red I have my -2, which is my y-coordinate, that's located over here again. My y-coordinate, which is -16, and in green I have my normal line m. Then my normal line is y plus 16 is equal to 1 over 19 times x plus 2.